Okay, hi everybody. So welcome to the first official day of e-learning where we're actually going to get grades. So the school set out a little bit of guidelines about what we're supposed to be doing and how we're supposed to go about this. So these days are going to be a little bit less long than the Act of God days. But just really quick, speaking of the Act of God days, I just want to thank everybody who took the time to do the work during the Act of God days. I know there's some circumstances where some people may not have been able to get to it, but the people who chose to learn and try something out and do something for the sake of learning, I really appreciate that. So thank you for those people who did that. And if you couldn't do it, don't worry about it. The stuff is there if you want to try it out. But I know there's some circumstances where some people may not have been able to get to it. But yeah, so thank you for the people who did do it. I appreciate it. So what we're going to look at today is we're going to be thinking, I'm kind of thinking about the Olympics. Now the Olympics are pushed back until next year. And one Olympic event I really like is archery. So I was just thinking about, okay, like, is there an ideal height? Is there a person who is a certain height, an archer, who could be a certain height so that every single time, without like aiming, without being like, okay, I need to go up or down like this, if they just launch it horizontally, is there some sort of height where they would be able to get a bullseye every time without even trying? They could just pull it back horizontal. As long as they pull it back the same amount, would they be able to get a bullseye every time? So I was thinking about that. That'd be kind of fun if they just had a really tall person who could do that. So what we want to do first is think about, is there a linear graph that we could make that could help us figure this out? This class we do a lot of graphing. We do a lot of graphical analysis. Is there some sort of graph that we can make to help us determine that? So what we're going to look at today is a quick video of some archery. We're going to look at this idea of linearizing data. I don't remember if we talked about it or not, but it is an important skill. So I want us to start off without thinking too much about content, getting a little bit more practice with this skill. So instead of reviewing, which we're going to be doing up until the AP test, on April 3rd, we'll figure out when that is. But we want to think about linearizing data, what that means, and why this is helpful. Then we'll do a little bit of practice linearizing data. So I'll give you 4 questions that we're looking at. I'll walk you through one. I'll let you try one and kind of say, hey, pause the video here. And then I'll say, hey, resume the video. And then you'll be able to look and see, oh, did I get this right? How did this go? And then I will give you an experimental design type question that will show you, hey, when is linearizing data actually useful? Then tomorrow we'll jump in and we'll look at this archery idea and thinking about when could we use this in this archery example. So what you're going to do today is, that's going to be collected and graded, is finishing up that Google Sheet, and then this quick little Google Sheet where you'll be linearizing an experimental design type question. So with the archery, we know a few things. We know, like, hey, the distance that the archer is away is 70 meters. The arrow is launched at about 67 meters per second. And the bullseye is 1.2 meters from the ground. And we want to figure out, yeah, what's the perfect height so that they could hit the bullseye every single time. So here's just a quick little video. I mean, you guys have seen archery. Let me just... These guys are crazy. Like, they seem to hit it like every single time. I think it said this guy won the gold. Like, it's crazy. So he's aiming, though. He's doing a little bit of aiming. What could we do if we wanted to get it without aiming? So I went ahead and I kind of made this height versus distance graph. If you look at it, though, the scale on this graph is really weird. We have 1, 2, 3, 4, 5 for our y's. We have 1,000, 2,000, 3,000, 4,000 on our x-axis. But yeah, like, this is a linear graph. How can we actually use it to figure out what height our archer needs to be? So that's really going to be our main question. How could we use this linear graph? So what we're going to look at first is this idea of linearizing data. So first off, what is linearizing data? So linearizing data is just a method of transforming the graph of our data into a linear graph. So we saw back here, we have a linear graph that we can look at, that we can use to help us think about data. Here's just a nice little example. A lot of the time we get these polynomial, we get these x squared, these quadratic type graphs, and we use these graphs, but wouldn't it be cool if we could look at this graph immediately and say, oh, I can understand some data from this. From a quick calculation, I can figure something out about this graph. So we want to be able to look at the slope of a graph and instantly recognize what the growth factor between our variables is. So a graph that we have like here in this case, this quadratic or this polynomial type graph, it's a good graph. It's nice, but we know the relationship for this is like y equals ax squared, but it's really difficult for us to get an a value from that to tell us, hey, how is y growing with x squared? That's really difficult. If we had a linear graph, we could just find the slope and say, oh, well, slope is our change in our rise over our change in our run, and that's super easy to calculate. Something like this, to calculate the growth factor between a y and an x squared relationship, that is really difficult. That's something that is really hard for us to do. So what we have to do when we do this is first we're going to have to identify the relationship between our variables. So we have to say, how are these variables, how are they related to each other? Then we're going to have to set up some sort of substitution. We're going to perform that substitution, then we're going to graph the substituted variables. So this sounds really tricky, but really what it is just a substitution, which you guys have done in math class. So I'm going to show you an example. Really quick, these are just our different factors. I'll just kind of reference these. But so we have something that is not really related. We just have y as a constant. Usually we won't really get with that. If we have a linear relationship, that's fine. We don't have to do anything because we know that our graph is already linear. If we have this inverse graph, we know that y is inversely proportional to x. So y is related to 1 over x. So then we'll have to do a little substitution with this one. If we have this polynomial, if we have this x squared graph, we say, oh, y is related to the square of x. Then we'll have to do a little bit of substitution with that. And then if we have this y squared versus x, we usually won't see these, but it's on our list of things that we have to watch out for. So I'm going to jump in and we'll do a practice one, and that will be in the next video. So I'll kind of show you a data set. I'll show you why we may want to linearize it, and then we will go from there. Okay.